well, good evening, everybody. As Harry said, I'm George. I work at thoughtbot. Thank you all for having a Vim user come and speak at the Emacs meetup. I'm very grateful to be here. I'll be even more grateful to get out alive. But editors aren't really going to come into this very much. Tonight, I'm going to be giving you what I hope will be a pretty good introduction to pretty good privacy. So first of all, what is it? What is PGP? What is pretty good privacy? Well, it is a security and encryption system. It's a very popular and widely used one. And it's an example of public key cryptography. So can I just get a quick show of hands of who's using PGP actively? All right, so a few people, but a lot of people new to PGP. So we'll go through this intro in detail. Public key cryptography is a kind of cryptography where you use a pair of keys. So we have one key which is a public key. That key we distribute as widely as possible. That's available on the internet. Anyone can get hold of a copy. The other key is a private key. That key is a closely guarded secret. I keep my private key to myself. No one else ever gets to see it. No one else ever gets to know what it is. And these keys are generated at the same time. So they're kind of inexorably linked through some clever mathematics, which some of you will be happy I'm not going to explain, and others of you will be disappointed, including Harry. But these two keys are inexorably linked, so that they are a pair, even though one of them is distributed on the internet and the other one is a big secret. And these two keys, this pair of keys, gives you access to two very useful functions. The first one is encryption. By encryption, I mean the ability to scramble a document in such a way that it's completely unreadable and only the intended recipient of that document can unscramble it. So if you wanted to send me a message that was for my eyes only, you could encrypt it for me. Now with public key cryptography in general and with PGP specifically, how that works is that you take your plain text document, it might say hello world in this case, and you run it through the PGP encryption program using my public key. This is the key that I'm distributing online for anyone to use. And you come out with something that looks completely meaningless. It's just a long string of letters and numbers. And no one else apart from me is going to be able to decode that. The only way to get back to the original document is to run that through a PGP decryption program using my private key to get back to the original document. So whichever public key this was encrypted with, it's the associated private key is the only one that can decrypt that. So we have private encrypted messages. Everyone with me so far? Great. The other function we get from having this pair of keys is signing. This is kind of the opposite way around. So instead of you sending a message for my eyes only, this is me wanting to send a message and say, this is definitely from me. You can guarantee that this is from me, and you can guarantee this hasn't been tampered with. It's like signing a paper document, except it's much more secure because it's mathematically verifiable, rather than just someone looking at it and going, yeah, that looks right. So this works in a similar way to encryption, but it's the opposite way around. So you have the plain text document, you run it through the PGP signing program. This time I use my private key, the key that only I know about. And it comes out with still the plain text document. Anyone can read it, it's not been encrypted. But I also get a digital signature, which again just looks like a bunch of meaningless characters. But when you run this document and the signature through a PGP verification program, along with the associated public key, you get out the original document still, but also a message saying, yeah, this has been verified. This document was definitely signed with this private key, and it definitely hasn't been modified since it was signed, which are two kind of useful properties. All right. So these are the two things that PGP can do. It can do encryption, it can do signing. So you all want to use it, right? Well, like, why should I care? Why are these two properties important? Why is the ability to encrypt and sign something that we might want? Well, there are a bunch of practical uses. There are a bunch of ways in my own personal interaction with computers on a daily basis that I use PGP. And I'm going to run through a few of them and hopefully convince you that this is a great idea and something you should be doing yourselves. The first is email security. Probably the most famous PGP user in the world today is Edward Snowden. Whether you think he's a hero or a villain is kind of beside the point. he was someone who wanted to discuss secrets on the internet, and he wanted to do it in a way that was secure and was private. He sought out journalists who had PGP keys. He wanted someone he could talk to privately. Now, I'm not saying he did the right thing or he did the wrong thing. I'm just saying that when he was looking for a way to talk privately about secrets online, PGP was his go-to tool of choice. But you don't have to be like breaking the law and sharing US government secrets to need this kind of thing. Just a couple of days ago, I needed to send a password to one of my colleagues. He needed access to an online system. It could generate passwords if you already had access, but it couldn't send the passwords directly to the people who needed them. Kind of a silly way to do things, but this is how it worked. So I needed to create a password for him and send it to him. I did this using a PGP encrypted email. Since he and I are both PGP users, I had an easy, secure way to get from me to him across the internet without this ever going in plain text. So that's kind of useful. Also, email signing. You can sign every email you send. Even if you're not sending it to a PGP user, you can include a signature. So you know that your message hasn't been tampered with en route. You know that when your message gets there, it's still in one piece. Or at least, if someone wanted to take the time to check, then they could check. Now, maybe day-to-day these things aren't going to kind of come into play, but it's kind of reassuring when an email arrives and your email software says to you, you know what, this is definitely from the person that it claims to be from. This is definitely not spam. This is definitely not a phishing scheme. This is definitely from the person who said they sent it. Imagine if your bank was signing the email that they sent you. Imagine how useful that would be if every time you got an email from your bank, you didn't have to go, okay, is this a scam or is this really my bank? And most popular email programs, at least all the desktop clients, like web clients not so much, but any desktop client, you're going to find a PGP extension. So you can just turn on email signing and forget that it's there. This really is, once you're up and running, email signing and when you need it, email encryption are incredibly easy to use. Signed Git commits. This is another way that I use PGP every day. Every single time I commit source code to a Git repository. So I'm assuming you know what a Git repository is because this is a meetup of people mostly using a programming editor. So Git is a tool for tracking changes in software. And every time you add a change to that software, that's called a commit. It's really easy in Git to say who the author of that commit was. I could claim that a commit that I had written was written by Harry. Sometimes that's legitimate. Sometimes Harry would come over to my computer and he'd say, oh, you fix it like this and write a quick line of code for me. I might want to commit that under Harry's name because he actually wrote the code. But what if someone gained access to your server? What if someone gains access to your Git repository and they commit code under your name and it looks like an innocuous commit, it looks like just some documentation changes or whatever, but they sneak in a security problem, they sneak in a backdoor. It would be great to know that that commit really was by the person who it claimed to be by. Signing commits with your PGP key is one way to do that. It's a way of saying, not only does this commit have my name and email address on it, it was signed with my PGP key. And unless someone managed to steal my private key, you know that that was me. You know that it was me who made that change. But also, if you're routinely signing every single commit, if a commit shows up that's from you, but it isn't signed, then people have a reason to ask questions. One of my colleagues is actually working on a GitHub README badge. Like you can get the badges in READMEs to say, oh, the tests are passing for this, or the code is of this quality. He's working on a badge to say all the commits in this repository are signed, which would be a kind of useful property to know. So we can use it for the security of our source code. We can also use it for encrypting files. I said that when my public key is out there in the world, anyone can take that and use it to encrypt a document for my eyes only. Well, I can also take it and encrypt a document myself for my eyes only. Do any of you use a password manager like 1Password or LastPass or anything like that? So I know a bunch of PGP users who the way that they do that, instead of using one of these tools, they just have a PGP encrypted file on their hard drive which lists their passwords. And you can just pull the passwords out of there. It's encrypted securely. Unless someone else has your private key, they can't get into it. This has actually been taken even further by a product called Pass, which is a command line password manager, which just uses PGP to encrypt all of your passwords. So you might type pass@gmail.com, and it's going to prompt you for your PGP passphrase via GPG agent or whatever you're using for passphrase management. We'll talk about that later. and then it will decrypt the password and show it to you. But there's no kind of, oh, I have to know another password for this thing. There's no, I have to rely on some company's proprietary tool, or I have to rely on like this one encryption scheme that this company came up with. You're using your own key. You're using your own like PGP encryption settings. So that's pretty cool, pretty useful. Verifiable downloads. How many of you, when you're downloading software, bother to verify the SHA-1? So you often get like a SHA-1 or an MD5 next to the download, and you can run the thing you downloaded through a cryptographic hash function, and you get the SHA out, and you compare it to the one on the website, and then you know that what you got is what you expected to get. Or do you? If I've compromised that website so that I can upload an alternative file, what's to stop me from also changing the SHA-1 that's next to it? So a slightly more secure way of doing this, well, actually probably a significantly more secure way of doing this, is to create a PGP signature for that downloaded file. This is quite common. You'll see the SHA-1, you'll also see an ASC file that you can download, and you can verify that signature with PGP. So you know now that not only has this thing not been modified since it was signed, you know which key it was signed with. And you can verify outside of the website where you downloaded it from that that key really belongs to the author. You can verify that without just having to read the page you downloaded the thing from. So it's going to be more secure than checking a SHA-1. And actually, if you're using Debian or Ubuntu, you're already doing this without knowing about it. The apt package manager system is using PGP behind the scenes. Just every time you apt-get install something, it's downloading the file, it's also downloading a signature, it's checking it was signed with one of a set of expected keys. So that's pretty useful. You had a question?
Yeah, I wanted to ask you that. Since you decrypt with your own private key, I'm not sure I understand the premise of this, but wouldn't that require them having access to your public key to first encrypt it?
So
Isn't that something that could be?
Yeah. So the question, just for the benefit of the recording, was if things are encrypted using your private, if things are signed using your private key, then wouldn't they need your private key in order to generate the signature? Is that what you were asking?
No, don't they need your public key in order to encrypt?
Oh, so they would need your public key to encrypt the file for you to download. So this isn't using encryption, this is using signing. So I, as the software author, would sign it using my private key, and then you could use my public key to verify the signature. Yeah, so sorry, it's a signature rather than an encryption. Because anyone's supposed to be able to download the software, so you don't want to encrypt it, but you do want them to be able to verify they got what they expected to get. One final use of PGP, this is not a very common one, but there's an experimental project that I really, really enjoy, so I wanted to demonstrate it, which is using PGP to create websites without passwords. So the way that you would post to, say, your Twitter account is you would send your password over to Twitter. They would verify that, yes, you are the person who owns that password, and they'd send back some kind of session ID in a cookie, and then you'd keep sending that back in a header with every request saying, hey, here's the session ID you gave me. And then because of that session ID, you'd be able to post content. Or alternatively, you'd go through like an OAuth mechanism, get a bearer token, and you'd send that in a header and say, hey, I'm allowed to post content. It's kind of insecure, right? The thing that identifies you, the thing that is uniquely you, your password, is going across the wire. And yeah, it's going over HTTPS, but you never know. HTTPS does use encryption, but the certificate is being issued by a central authority rather than the kind of distributed mechanism of PGP, which you could argue makes it inherently less secure. Like if the certificate signing authority has been compromised in some way, then anyone can pretend to be Twitter, and you're never going to know.
That's what that Reagan thing is, right?
The
Reagan, the new Reagan, the new APT they found in Hungary, because it was attacking a certificate authority.
Okay, I hadn't heard about that, but yeah. This is exactly the kind of thing you could do to try and get around SSL, which wouldn't work with PGP. So what the website I'm about to show you does instead is it says, okay, never send any identifiable information like that could be used to impersonate you over the wire. Instead, just sign your content locally on your own computer using your own key, and then send the signed content to the website. And from that, they will figure out your identity. They will group all your posts under a profile for you. The website I'm talking about is called Manifesto. So this is my first post on Manifesto. It says, welcome to the New York Emacs Meetup holiday key signing party. And I didn't have to create an account. I didn't have to send a password. I just sent them a signed message. Now, this isn't very common. You know, this website is fun and cool, and I encourage you to check it out. But really, the reason I have for showing this to you is to think that PGP is not just about the things that people are using it for every day. It's not just about signing email and git commits and encrypting attachments. It's not only about those things. Anywhere where you need identity verification, anywhere where you need encryption, this is a useful tool, and you can reach for it. So you're all excited now. Have I convinced you that the PGP is worth using? It's a very enthusiastic response. I think I'm getting through. So now it's time to hit you with the problem.
I think there's an additional argument to using encryption.
Okay.
And it's to ensure that we don't create centralized pools of information that can be used by third parties without our knowledge. I think that's, for me at least, the main reason to encrypt anything.
So you mean so that someone can't harvest all of your email, for example, and then use all that content against you?
Not
or
specific individual emails, but all of emails. That pool of information can be like, we can fight that danger that inherently lies in a lot of information centralized.
Yeah, absolutely. Like, I mean, even if you're just uncomfortable with the idea of Google scanning your email to show you ads today, but who knows what tomorrow, if you're encrypting your email, they can't do that. So, yeah. Definitely another argument for using encryption. But there's still a problem with PGP and with public key cryptography in general, which is which comes first, the chicken or the egg? So let me explain what I mean by that. I've said that using your public key, I can verify a signed message from you. So I have a way of knowing you're the sender of that message once I have your public key. In order to get your public key to me, I could really use some way of knowing that you sent me a message, but I don't have one until you give me your public key. It's really frustrating, right? Like, if I had your public key, you could securely send me your public key, and I could know that it came from you, but I haven't got your public key yet, so you can't. How do we get keys from people and know that they really belong to the people that they say they belong to? Every key has one or more user IDs attached to it, which consist of a name, an email address, and a comment. But I could create a key right now, and I could type any one of your email addresses and any one of your names. I could create a key in the name of Harry Schwartz, and I could upload it to all the public key servers, and I could distribute it on the internet. How would any of you know that that key belonged to me and not Harry? How would any of you know when you search for Harry's key and you find two matches, which one you want to download? It's a problem. PGP's answer to this is called the web of trust. For which I would like to give you a practical demonstration of how this would work in real life with real humans. Harry, can I borrow you for a minute? This is Harry. I know this is Harry. We've met before. I work with him. I trust him. You know, I've known him for a while now. Unfortunately, and sorry to pick on you, but I don't know you. Sorry, what's your name?
Aaron.
Aaron. Hi, Aaron. I don't know Aaron. I mean, Aaron's just told me his name is Aaron, but how do I know his name is really Aaron? Well, I've known Harry for a while. Harry's been running this meetup for a while. He probably knows. Harry who's that?
That's Aaron.
That's Aaron? Cool. Okay, hi, Aaron. Nice to meet you. Right. This is the web of trust in real life. This is how the web of trust works. You have trusted introducers. I trust Harry to introduce me to people. He introduces me to Aaron. And I have more reason to believe this is Aaron, because I have Aaron's word for it, but I also have Harry's word for it, and I already trust Harry. But, you know, this is the world of cryptography, right? We like things to be mathematically verifiable. We like things not just to be, well, Harry said it's all right, so it's probably fine. So the way that this gets modeled in PGP is by signing keys. So I've said that I can create a signature for any kind of document or message using my private key, and you can verify that that came from my private key. So the way that what we've just seen would work is I would sign Harry's public key with my private key. Harry would sign Aaron's public key with his private key, And at the point where I got a message from Erin and I wanted to verify that it really was from Erin, then my PGP tools would say, oh, well, you have signed Harry's key and you've said that you trust him to introduce people. He signed Erin's key, so therefore Erin is really Erin. It's as simple as that. And you can make it more subtle if you want to. Like, you can tune this algorithm, you can tune this verification algorithm for your needs. So the default is that if you trust someone fully, then if they have signed someone's key, then you will trust that key. If you trust someone partially, if they and 2 others have signed someone's key, then you will trust that key. So I can say, like, well, I trust Harry because I work with him. I maybe trust Erin a little bit because I met him at an Emacs meetup, and I don't know, Emacs users. Who can say? I have to get a few digs in. I'm sorry. So what we're going to be doing at the end of this evening is a key signing party. We're going to be verifying each other's identities as best we can, and then we're going to be telling each other, okay, this is the key that I own. And once you know who I am and you verified my identity as best you can, and if you trust governments, I've brought ID from 3 different governments, so you can check what the UK, Swedish, and American governments say about me. It's complicated, don't overdo it. But if you trust governments, you can verify it that way. I can send you encrypted email if you want that. I can send you signed email if you want that. You can verify that I own the key that I say I own and that I am who I say I am, and then you can sign my key. And by all of us signing each other's keys, we get lots more links in this web of trust. And the more links there are in the web of trust, the more well-connected everyone becomes, and the easier it becomes when I get a message from someone I've never heard of before to go, oh, look, I can hop this way through the web of trust. And I can get to that person. So how do we use it? Now that we've talked about what it is, what it does, let's get down to some actual practical usage stuff. So I've been talking about PGP, and I keep saying PGP over and over again. What do I actually mean by that? Well, the original PGP tool was written by Phil Zimmerman in '95, I think, around then, mid-'90s. It's free as in beer. It's not free as in Stallman. You can download it in source code form, and you can compile the source code for yourself, but you can't modify and distribute the source code. So you can look at the source code from a kind of, let's check this is safe and doesn't have security holes in it kind of point of view, but you can't then make your own versions and distribute them. From PGP was derived a standard called OpenPGP. That is an RFC 4000 and something, I think. I forget the number. But there is an RFC which you can go and read that defines how an OpenPGP compliant thing should work. And so the good people at GNU have made an implementation of OpenPGP called GnuPG, or GNU Privacy Guard, GPG, you'll hear it called, all of these things. GPG is free as in beer and also free as in Stallman. Being GNU people, and also because it's what I used, I figured I would demo a GnuPG, although I hear from PGP users that the command line interface is slightly less confusing. So it's maybe worth giving it a look if you're not into GnuPG. It's also worth noting that there are a ton of plugins for email clients. There are a ton of GUIs. If you don't want to mess around with all this command line stuff that I'm about to show you, then you really don't have to. But it's a developer tools meetup. We can get nerdy. We can do it on the command line. So now, I claimed when I was talking about the web of trust to have signed Harry's key. I actually never have signed Harry's key. I keep meaning to, but what better time than now? Although first, I should show you how to create your own key. Actually, if you don't have a key, I'll show you how to create one. Then we'll get on to signing. Sorry, I'm jumping ahead of myself. So first, you'll need to have GPG installed. You can probably get it from your package manager of choice. It's definitely in apt. It's definitely in Homebrew. Whatever else you use. I'm sure someone can help you out if you can't find it. And then you use the command gpg-gen key to generate a key. You're going to get a bunch of questions at this point about how you want this key to be set up and how you want it to work. If you're just getting into this for the first time, I would say the defaults are probably fine. Someone who is actually a more hardcore security expert than me, I'm just an average PGP user, but someone who's a security expert may tell you differently. but I'd say the defaults are going to be fine for your first key. So let's use an RSA key. That's the default. And again, the key size may be between 1024 and 4096 bits. The larger the key, the harder it's going to be to crack, but also the larger the key, the larger the signature and encrypted documents that are going to be generated are. So, you know, the default is right in the middle, kind of a balance between security and file sizes. So let's go with that. How long should the key be valid? Your key should probably expire. Let's go away from the default a little bit on this one. The reason is if you lose the private key, if you say it's only on your laptop and your laptop gets stolen, or the hard drive crashes and you've no way of getting it back, and you don't have it backed up, and you've not got that private key anymore, for whatever reason it happens, and the public key is still out there, people will send you encrypted documents that you can't ever decrypt. This happened to me this week. I sent someone an encrypted email through no fault of their own. They'd lost the key. It happens. They couldn't decrypt it. So your key should probably expire because then, you know, if you do lose the private key, then at least the public key is going to disappear after a while. And you can always edit the expiry date anyway. So if, you know, it comes up to 2 years or whatever you set the expiry to, and it's about to expire, you don't have to make a whole new key. You can just update the expiry date. So let's go for 2 years. So it's going to expire on Wednesday, the 7th of December, 2016. That sounds fine. So GnuPG needs to construct a user ID to identify your key. You know, like I said, I could type in anyone's name. And I'm not actually going to type in my own name now because I already have a key and I don't want to get confused and delete the wrong one. That would be horrible. So I'm going to be called Testy McTest. And my email is test@example.com. You can enter a comment here if you want to. I'm not going to. You can add multiple user IDs to your key though. So for example, my primary user ID is my name and my personal email address, and my secondary user ID is my name, my work email address, and the name of the company I work for is the comment. You could use the comment that way. Other people use the comment to describe what this key is for, like this is my general signing key through to the year 2016 or whatever. But let's just leave that blank. So testing test at test@example.com, that all sounds okay. I need a passphrase for my key. So I mentioned that the private key is secret. You keep it to yourself. You never share it with anyone. As an extra layer of security, every time you use the private key for something, you also have to enter a passphrase to unlock it. It's probably a good idea for this to be a reasonably strong phrase. I'm going to choose a terribly insecure phrase, 1, 2, 3, 4, 5, just because this is an example. But you really shouldn't use that. Yep.
Just for the recording or anyone, like, why do we call it a passphrase and not a password? 1, 2, 3, 4, 5.
That's a good question. The question was, why do you call it a passphrase, not a password? The reason is to encourage you to pick something longer and more complex than a single word. You don't really want something that's just a word, and just the terminology passphrase is trying to nudge you in the direction of choosing something more long and more complex, as I understand it. There may be other historical reasons. Everyone's nodding. Cool. So I have to re-enter my passphrase, 1, 2, 3, 4, 5. Oh, this text size is actually too big to read the output. Let's shrink that down a little bit. Sorry about that.
Yeah, it says to me, we need to generate a lot of random bytes.
Yep.
Okay, and it says not enough random bytes, and I type randomly, which I'm fairly good at.
You have to keep
Still-
placing.
If you move the mouse and use other applications, that will
on the mouse.
that will generate randomness.
The mouse will give you the most entropy.
Okay.
No, I'm not good at mouse.
You don't need to do anything detailed with the mouse. Just move it around at random. So yeah. Again, for the recording, if you're getting a message saying we need to generate a lot of random bytes, going and doing other things and moving your mouse around a lot is a good way to do that. You'll get a lot of entropy, and then you'll get some random bytes. Okay, so we have created our key. Sorry, this input would wrap more nicely if my font size hadn't been huge, but you will see this line in the output. Oh, that's really unreadable. Okay, let's go back up. How's that? you'll see this line in the output which identifies your public key. So pub for public, 2048 bits RSA key, and then this part is important. This next piece is your key ID. This identifies your key. You don't need to memorize this. It's something that you can get out of the PGP tools again if you need it. But we're going to use it right now. We're going to use it immediately to publish this key to a key server so that anyone can get our public key and start using it to send us encrypted things. So I can say GPG, if my terminal wasn't screwed up. Hello? Okay. I don't know what happened there. There we go. GPG-send key, and then the key ID that we got from the output. And that's going to publish the key to the key servers. Now this is just an example key for a user who doesn't really exist, so I don't want to pollute the key servers with this fake key, but if I hit return it would publish this up to a key server. The default key server is fine. The key servers will kind of share information with each other, so there's a whole network of them. MIT run one, GNU run one, and if you upload your key to one, it will eventually find its way to all of the others. So once you've sent your key, you're ready to start using it. If you forget what that key ID is, by the way, you can use gpg-list keys and then your email address, which I think was test@example.com, and it's going to tell you again like this is your public key and this is your user ID. So this part here on the pub line is the C19B0406. That's the key ID. If you need that again. Okay, we have a key. Is everyone happy? Oh, question?
Yeah, just one question. So when you did list keys, it was like something / the key ID? What was that thing in the beginning?
Oh, sure. So that's the type of key. So it's a 2048-bit RSA key. And PGP supports a bunch of different encryption algorithms, essentially different ways of mathematically producing and using the two keys. I am not enough of an expert to explain how all of them work. RSA is the default one, so this is an RSA key. There are a bunch of interesting new ones in PGP 2.1. You can do things with elliptical curves, which are quite interesting. But yeah, if you're setting up your first key, then I'd go with the default RSA.
Well, I made a shorter key of 1024, but my randomness is still not enough. I'm too predictable, I guess.
It took me 10 minutes.
It took 10 minutes. It takes 10 minutes.
I don't know if it takes normal people.
Okay, so it does take some time. So we just have to be patient.
Yes.
Yeah.
Okay.
The way randomness is generated is going to vary from machine to machine, but
Yeah.
generally just keep doing other things, keep moving your mouse around, keep running other programs, it will get there eventually.
Thank you.
All right, so let's sign a key. Let's add a link to the web of trust. And Harry, I'm going to ask you to volunteer again now,
Okay.
because I'm going to sign your key with my real key, not with the test key that I just created. So,
Everyone's done.
yeah. So there are two important pieces to signing a key. The first one is verifying the identity of the person. So the information in the user ID, the key we just created, that was the name testy.mctest and the email address test@example.com. You want to verify the information in the user ID, check that that person really is the person that's mentioned in the user ID. And then the other important part is verifying that the key you have for that person is the key that that person themselves controls. So as the person signing the key, I'm very interested in the identity verification part, and I'm also interested in the key verification part. As the person whose key is being signed, you are very interested in the key verification part. You don't want anyone to accidentally sign the wrong key saying, yep, this is definitely Harry, when it's not Harry. So first of all, Harry, are you really Harry Schwartz?
I am indeed.
I don't believe it.
Can you prove that?
I can. I have here government issue ID.
Oh, thank you. So someone raised the interesting question before of what if you don't trust governments, which is a valid question. Generally, I think photo IDs, because they're kind of hard to forge, especially if someone happens to have multiple, that's a reasonable proxy of confidence. But we'll talk about how to mark the confidence of the signature in a second. So yeah, that seems fine to me. Your name is Harry Schwartz, and
Looks more or less like.
yeah, it looks like you.
Sure.
All right. Well then, I'm happy to sign your key. So first of all, I need to find a key. Like, who's this Harry Schwartz guy? So what's your email address, Harry?
I have two. One is hello@harryrschwartz.com.
Have I spelled your name correctly?
You have.
Cool.
You could also have used harry@thoughtbot.com.
Hey, look at that. This key has 2 user IDs, Harry R. Schwartz, harry@thoughtbot.com, and hello@harryrschwartz.com. That's great. So I'm going to download key number 1. Now what this gpg-search command I've just used has done is it's connected to a public key server. One of the same public key servers you send to is sendkey that we just used a minute ago. And it said, hey, is there any key that matches this email address? And this is the one that I found. And there's only one, which makes things easier. So I'm going to say, yeah, number 1, that's the one I want. And hit return. And it's downloaded the key for it and added it to my local keyring. So the keyring is the keys that I have saved on my computer that I might want to use for verification or encryption, that kind of thing. Before I can encrypt a document to send it to Harry, first I need to get his public key. So I do that like this. All right, so I'm now going to sign this key. I'm going to use -edit key, and this is where I have to ask cert level. There we go.
You can also add that to your gpg.conf, so it does it every time.
I know, but I wanted to demonstrate it. So, yeah, so I'm going to use the gpg edit key command, and I'm going to ask for the cert level, and the key I'm going to edit is, I could copy the key ID here, but I could also use Harry's email address. So I'm going to edit Harry Schwartz's key. So now GPG launches this little interactive program, this little key editor shell, where I can edit the key. The first thing I want to do is verify which key this is. Now you might recognize this line, the pub 4096R/key ID line from when we generated our own key. I could just check with the key ID, but the key ID is quite short. And there are often collisions between key IDs, and it's also apparently possible to maliciously generate a key with a specific ID if you really, really wanted to. So probably shouldn't just use the key ID when we're verifying which key this is. We should probably use a longer representation of the key. And there's one called the fingerprint. So I can type FPR at this edit key prompt, and it's going to tell me a fingerprint for Harry's key. Now Harry normally would not be looking at my screen at this point. He's kind of cheating. And then I'd say, hey, Harry, can we compare fingerprints and check we have the same key? What does your key begin with?
1B41.
That sounds right.
8F2C.
Yep,
23DE.
yep,
DD9C.
yep,
807E.
yep.
A74F.
Can I stop you there? Harry may also, if he's paranoid, maybe want to get me to read out a few segments of the key ID too. It's not really necessary. I mean, you know.
I mean, I just visually verified it, so I'm pretty comfortable.
Yeah, but you will often hear like people reading 4 characters from one, 4 characters from the other, back and forth, kind of like checking that neither one of you reads more than half of it, and you both have the same thing. Not completely convinced it's necessary, but it sounds kind of cool. Yeah, so you verified this is the key ID?
Let's see. I do. That's right.
Cool. Now, remember that when I ran the edit key command, I used this ask cert level option? So the ask cert level option means that when I now type the sign command, it's going to say, really? Sign these user IDs? By all these user IDs, it means Harry R. Schwartz, harry@thoughtbot.com and harry@harryrschwartz.com. I want to sign both of those, so I'll say yes. But now it checks the level to which I've verified the key I'm about to sign. So the default is no answer. But you could say I've not checked at all, which you probably should check. You could say I've done some casual checking, and you could say I've done very careful checking. In this case, I know Harry, we work for the same company. I've seen his name in our company records and places that he hasn't written it. I've seen his ID. I've known him for a while. I'm pretty confident. We've exchanged emails, we've exchanged signed emails. Like, I'm pretty confident that this really is Harry. So I'm going to say, number 3, I've done some very careful checking. I've checked this key very carefully. There's a lot of confirmation in this process. It's kind of important that,
about the equivalent of like testifying, being willing to testify in court with that person as soon as they say.
Yeah.
That seems about right.
That seems about right. Oh, no, I don't know.
George,
Eric.
what's the point of saying I will not consent versus I have not checked all? Just to sort of leave it as is?
Well, the default behavior of GPG, at least, when you sign a key, is not to set this certainty level. So the I will not answer is just, it's kind of a, you can't like guarantee anything either way. You can't guarantee that I have, you can't guarantee that I haven't. It's just a signature with no assertion of what it means. And then the others are, I'm signing this and I'm making an assertion about what this means.
What's a sub key?
Sorry?
You had a pub and a sub.
Oh, so sub, let me get into that at the end once we've done this, because it can be a fairly broad topic. Yeah. All right, so I'm really going to sign Harry's key. Now I need to enter my passphrase, which I'm inevitably going to get wrong. Oh, I got it right. Cool, so I've entered my passphrase to use my secret key to sign Harry's public key. And now I finish it off the process by typing save. And then I want to send Harry's key up to the server. And for that, I need Harry's key ID. So I can use list keys to get that. Grab his key ID, and then send key with his key ID. And that publishes Harry's key with the signature that I have just added to the key. It's not going to overwrite anything else about the key. It's just going to add my signature to the key that's already up there. So like if I sign the key and someone else signs the key and we don't re-download in between, it's going to be fine. PGP will work that out. And we're done. That's how you generate a key. That's how you sign a key. You can also sign and encrypt documents, which actually, I suppose that's worth demonstrating. If I wanted to sign something, I could use something like that. Oh, wait, what? Is it just that? How would I? Oh, I guess I'm just going to have to type, aren't I? It's great that I always forget how to do basic command line stuff whenever I'm on a screen in front of hundreds of people.
That's why you have to do live demos. Right? There you go.
There we go.
So, George, what's your technique then for keeping your private key consistent between machines? Do you have sort of a, and definitely don't put question for anybody else that uses GPG.
Yeah.
You're going to want to keep your same private key, I assume, between machines, right?
So actually that ties into another question about subkeys that was just asked. So there are two approaches to keeping your keys consistent across machines. One is that you just copy the key around, preferably not over the network, preferably on a removable media that you trust. If there is removable media you can trust, it depends on how deeply you want to think about these things. But for example, a USB key, you could copy it between machines that way. But another approach that people take is to create a master key that kind of represents their identity, and then create subkeys, which is what you were asking about, for each device and each situation that they might need a key in. So if, for example, you wanted to sign email on your phone is a lot more likely to be stolen than your server that's sitting in a colo somewhere, right? So you take your phone with you when you go out. So if you have a subkey on your phone, you could revoke that subkey without having to revoke your main key that represents your identity, which means all of the signatures that you've acquired that kind of verify your identity aren't lost when you revoke that subkey. So one approach is to have subkeys for each device. I currently don't do that, but I currently only use my key on one machine. But once I move away from an Apple phone and I'm willing to put any kind of key on my phone at all, then I intend to generate a subkey to do that. Yeah. Hang on.
You've seen services like keybase.io, and if so, what do you think?
Yes, so keybase.io, have I seen it, was the question. It's a web service for kind of, they want to promote PGP use, which is a really good thing. And they kind of do three things, one of which I think is great, one of which I think is and then one of which I think is terrible. So the one that's great is that they let you verify your social media accounts by posting signed data. So they've come up with like a standardized way of saying, if you post a tweet with these bits of signed data in, we will find that tweet and check it with your public key and say, yep, the person who owns this PGP key and the person who owns this Twitter account, they are the same person. We have verified that. And that's a really good service. And they do that for Twitter accounts, GitHub accounts. That's pretty cool. Especially, you know, if you're signing your GitHub commits and then there's kind of a way of verifying, yeah, this GitHub account belongs to the person who has this key. That's pretty cool. Then there's the idea, which is they have this follower model, which they kind of intend to replace the PGP Web of Trust. I really like the PGP Web of Trust. It's really flexible and really powerful, and it allows you to kind of capture some of the subtleties involved in human trust. Like, for example, I may be a more trusting person than others, so I may, you know, require a lower threshold to trust someone's key, or I may be a less trusting person than others and require more signatures and more verification to trust someone's key. Keybase don't really do that. They more have like a Twitter follower kind of model where it's like, hey, I follow you, so, you know, that's cool. We're friends. I trust your key now, that kind of thing. It's not quite as rigorous, so I'm not really into that. But, I mean, you know, good on them for trying to make this easier than all this, like, command line key signing stuff. You're right in front of the projector there, covering up my key fingerprint, which you could all write down if you wanted to sign my key. And then the third thing that they do, which is absolutely appalling, is that they encourage you to upload your private key to their server. You should never, ever do this. The reason that they do that is that they want you to be able to do PGP operations in browser. And they kind of say, oh, well, you just log into our website and we never have your passphrase, but then your private key gets downloaded to your browser and some JavaScript runs, and then you enter your passphrase in the browser, but we don't transmit it to a server, honest. And then, you know, you can do cryptography in the browser, and isn't that great? Except that, no, it's not great. As soon as their servers get compromised, well, A, you may never know, and B, you've already put your private key in the hands of someone who isn't you. And even though they don't know your passphrase, they've got your private key. They can sit there all day trying to figure out your passphrase. They've got all the time in the world. So I did open a Keybase account because I use PGP and I want to promote it and I was curious. But once I saw how heavily they pushed the upload your private key thing, I don't think I'm going to use them again. And there's actually, they're open source, and there's an issue on a closed issue on their GitHub repo, which is basically lots of long-term PGP users coming and saying, hey, tried out your service, you wanted my private key, that's not cool. And the people from Keybase going, no, but it makes it easier, so shut up, we don't really care about security. They don't really say that. They do care about security, they just think that a passphrase is secure enough. I personally don't agree with them. I mean, if that were the case, why would we need private keys and all this cryptography stuff in the first place? So yeah, have heard of them, love-hate relationship. Probably wouldn't recommend using them because of the private key thing.
Have you ever had any experience using PGP with SSH? So I heard that there's a way to use your PGP key for SSH.
I have heard this too. I've never tried it. Has anyone else tried using PGP with SSH?
Yeah, so I have a config file and public private key, and I can SSH into machine home, or I can SSH into servers. I actually wanted to ask a question. Is there a way to use your public, is there an extension where we can use our public private key with something like Gmail instead of passwords and all that?
I did see something a few months ago. It was an experimental Chrome extension. So the question was, can you use your public private key with Gmail or a browser-based thing? There was an experimental extension from Google, which would allow you to do specifically PGP email with Gmail. I'm seeing people do this. I didn't get around to trying it. One of my colleagues used it to generate a key. He sent me the key so that I could send him encrypted email and stuff. I was busy that week. I never sent him encrypted email and stuff. Who knows? Maybe it would have worked. But yeah, I haven't seen anything solid to do this in a browser-based tool. I use Mutt for my email. It's really easy to do PGP with Mutt. I hear you can do it in Emacs too. Apparently your text editor does email. These Emacs jokes, man, they're really not going down well with this crowd. Any other questions? Oh.
Just so you know, Emacs will also do transparent files encryption with GPG, which is a really cool feature.
Nice.
It's a great walkthrough somewhere on the internet. You can probably find it from the Emacs wiki. It's really nice, so you can have a file. I'm pretty sure all you have to do is have a .gpg extension, and then it will do the right thing.
Cool.
Which is really, really awesome.
That's really nice. Yeah. For what it's worth, Vim also has built-in PGP support for, I think there's like a :encrypt command or something, but it's not quite as smooth, I don't think, as just having a GPG file extension and then it doing the right thing. Cool. Any other questions before we get into key signing stuff?
That's really you.
That is really me. That is really my...
That's not the email
Alright.
you have associated to it, right?
I have multiple user IDs on that key, and one of them is that email address. Another one is my personal email address. Yep.
This is a little bit outside the scope of, how does PGP work out, but how do we, I don't really use it. At one point I tried to get my dad to set it up with browser extensions and Gmail and Firefox. It was awful.
Mm-hmm.
And most people, at least that I know, don't use an installed email client. They're using Gmail, they're using pretty much just email. Do you have any thoughts on what we can do?
There are a bunch of reasons why I wish fewer people would use Gmail specifically. And one of them is that it makes it really hard to do things like PGP. You're kind of giving away your own decisions over how you handle your email, which is why I use Mutt rather than using the Gmail web interface. Although I admit I am still using their email servers because their spam filtering was really, really good until about a month ago. But yeah, I don't know what we can do. Phil Zimmerman always intended PGP to be for normal people, not just for programmers and nerds. And it's never really broken out beyond programmers and nerds. I suspect we need better tools. I suspect we need some good designers to get involved in this kind of thing and to care about this and to try and figure out some of the UX. Yeah, but I don't know how we get just your average computer user to start using PGP.